Alright guys, this is the last lesson for Chapter 1, Lesson 1-7, and we're going to talk about ratio and rate problems. And this is 11-7-18. So, I don't have a copy of the hard copy of the examples. You guys are going to have it, so I'm going to be writing mine out, but I'm going to do it offline, so we're not going to waste a lot of time in the video. So we're going to split this into basically two parts, and we're going to start by talking about going about solving ratio problems. Okay, so I'm going to give you some suggestions of strategies you can use. And we're going to demonstrate 3 different strategies. So the first one that you might see me use is using a bar diagram. Oops. Okay, the next one we're going to use, so you can see how it works, is use equivalent fractions. And the third strategy we're going to use to solve ratio problems would be a ratio table. So you get to kind of pick what you want to try. So I'm going to show all 3 strategies on the next 2 problems. So I'm going to solve one problem 2 ways, and then the last problem a different way. And then we'll talk about rates. Okay? Okay, so in a survey, 4 out of 5 people preferred creamy over chunky peanut butter. There are 120 people shopping at the grocery store. Use the survey to predict how many people in the store would prefer creamy peanut butter. So let's start. We're going to do this problem 2 different ways. We're going to start by demonstrating how to solve this using a bar diagram. Okay. So first thing I want to look at is this 4 out of 5 business. 4 out of 5. So these 2 numbers are going to be kind of important. When I create my bar diagram, I'm going to create 5 bars. And these bars are all going to have the same value inside of each of them. So pretend they're all the same length. I didn't do the best job drawing that. So I know from here to here, that's going to count for all 120 people. So what I need to do is to figure out how many times 5 goes into 120, because then that's going to tell me what goes inside each of those. So 5 goes into 20 twice, which is 10, with 2 left over. Bring down the 0, and 5 goes into 24 times evenly. So what that means is each of these represent 24. That deals with the 5 in the 4 to 5. But then we want to look at who prefers the creamy, and it said 4 out of 5 preferred the creamy. Okay. That means this last 5th one is for the people who like chunky peanut butter. Okay. So what I want to do is figure out what 24 times 4 is. I get 16, 8 and 1 is 9. So what we could conclude is that 96 people in the survey prefer creamy peanut butter. That's a lot of people, right? Okay. So not everybody likes doing bar diagrams, so let's do the second strategy. Let's do the same problem, but let's try it with equivalent fractions. Now, the problem with this strategy is that you got to have numbers that you know are going to go into each other. If you don't, then this strategy is not a really good one. Okay, now we kind of already cheated and we've done some of the work without really thinking about it. So we had 4 out of 5, and we want to change that into something out of 120. So what I need to do is to figure out how many times 5 can go into 120. So the part I just said that we already kind of cheated and already got this, I already know how many times 5 goes into 120 because I just calculated it over here. So I know it goes in 24 times. So if I multiply top and bottom by 24, I'm going to get the 96 out of 120. And then I would be able to conclude that 96 people out of 120 surveyed, so here's another way of saying that, preferred creamy peanut butter. So let's take a minute, butter, not butter, oh my goodness, peanut butter. So let's just take a moment and kind of look at how this problem was set up. What is matching here is basically they took the total number of people who liked creamy peanut butter out of all the people surveyed, and when they simplified that ratio down, that's where the 4 to 5 comes from. Now, both 5 and 20 are representing the same thing. These represent all the people. All the people. And on the flip side, the 4 and the 96 represent those who prefer creamy peanut butter. Okay? Now, we always have like things across from each other in our ratios. So the numerators have to represent the same ideas, and the denominators have to represent their own ideas. Okay? So there's 2 ways to solve the same problem. All right, we're going to do a second problem, and this time I'm going to show you how to use a ratio table. So hold on. Okay. So in question 2, a survey found that 12 out of every 15 people in the United States prefer eating at a restaurant over cooking at home. If 400 people selected eating at a restaurant, how many people took the survey? So I want to show you how to do a ratio table on this problem. Okay, so we're going to have eat at home versus people surveyed. So that's going to be everyone. And the top one is the part. It's like part versus whole. So we know there's 12 people out of 15 surveyed prefer to eat at home. So our goal, we got to remember, where are we going to put that 400? So that said, those are the ones that were surveyed. 400 of them selected eating at home. Okay, so now I got to figure out what to do. I need to get 12 to become a number that can go into 400. And I know 12 doesn't go into 400 because 12 has a factor of 3 in it, and 3 doesn't go evenly into 400. So, looks like I'm going to have to try to scale back, maybe? Let's see. If I divide by 3, that's going to give me 4. Ho, ho, I think I'm on to something. And I can divide 3 out of 15. So they both had a 3 in common. So that gives me 4 out of 5. Okay, ooh, that's interesting. Didn't we just have that number in the last problem? And then what we're going to do is we're going to scale up from 4 to 400 by multiplying by 100. Okay, so what we end up figuring out is that 500 people took the survey. Okay, so that's an example of how we can use a ratio table. Okay, so now what I'm going to do is talk about 2 more examples, and this time we're going to talk about solving some rate problems, and there's only going to be 2 strategies I'm going to talk about. So hang in there and we'll get to it. Okay, so now we're going to talk about 2 strategies solving rate problems. So strategy number 1 is going to be to use a rate table. Ooh, let's go back to green because we did that one. So rate and ratio are somewhat the same. So, oops, golly. So we're going to use a ratio table. I think I said rate table, sorry. And then the second one is going to be a little bit interesting. It's going to be use unit rate and multiplication. Okay, so we're going to do 2 separate problems, and we're going to use one strategy for each of the problems. So hang in there. So there are 810 calories in 3 scoops of vanilla ice cream. How many calories are there in 7 scoops? So I have calories and I have scoops of ice cream. Question is, how many calories are there in 7 scoops? So let's start with what we have. This one I want to use the unit rate and multiplication. So I have 810 calories in 3 scoops. So what I'm going to do to get a unit rate, remember, is to get 1 in the denominator. So I'm going to divide top and bottom by the denominator. Okay, that gives me, let's see, 1 scoop in the denominator. And then if I don't know the math, I'm just going to off the side multiply or divide 3 into 810. 3 goes into 8 twice, which is 6 with 2 left over. Bring down the 1. 3 goes into 21 7 times. Nothing left over, and there's an extra 0, so I am going to have to hold its place in the answer. So I get 270 calories in 1 scoop. All right, so now what I'm going to do is I'm going to take that 270 calories per 1 scoop, and I'm going to multiply it by the number of scoops. Now, this is kind of like dimensional analysis, right? Actually, I'm going to change that color. So I multiplied because what I want is to get rid of the word scoops and get the answer just in calories. So off to the side, I'm going to go ahead and multiply 270 by 7. So I get, sorry, I'm jumping the gun there. I get 0, I get 49, I get 14, and 4 is 18. So the answer, 270 calories in 1 scoop, is going to give me 1,890 calories in 7 scoops. So I take that answer and I say there are 1,890 calories in 7 scoops of vanilla ice cream. Okay? So that's how I use that strategy. Ooh, I forgot to write it down. Let me write it over here. Unit rate plus multiplication. So it's 2 steps. Well, that looks lame. Multiplication. That's better. Okay? So that's the strategy I used here. All right, I got one more question, we'll be done. Okay, while resting, a human takes in about 5 liters of air in 30 seconds. At this rate, how many liters of air does he take in during 150 seconds? So I've got liters of air, seconds. Liters of air, seconds. So what I'm going to do is try a ratio table on this problem. So I've got air, which is measured in liters, and I've got seconds. Well, I made that extra big, didn't I? And I'm going to do my 3 columns. And we have 5 liters of air in 30 seconds, and then we've got 150 seconds. So my job is to try to figure out how many liters of air matches with 150 seconds. And remember what I talked about before with our ratio tables is that sometimes they give us all these extra columns. Sometimes we can go directly from what we have to our target number. And this is one of those cases. If I multiply 30 by 5, that gives me 150. So if I multiply 5 by 5, that's going to give me my mystery number of 25. So I can say there are 25 liters of air taken in, so that's like inhaling, during 150 seconds. So notice I just basically take the question, rewrite it as a statement, and include the answer in it. So overall, guys, all I'm doing is providing you with alternative ways of solving these types of problems. Some strategies work better in certain situations. Some won't work at all because the numbers aren't going to be nice. Like, for example, I can't get 7 probably to go into a lot of stuff, so that's going to make a problem more challenging for me if I'm trying to do ratio tables. So you just kind of see what works, but notice that we have 5 strategies. Well, actually 4, because we talked about a ratio table for both of them. Unit rates specifically for rates. All right, so good luck with this. We'll talk later.